Now what we're gonna do today in this video is convert reoccurring non-terminating decimals into fractions. So we'll just do it by the traditional method once. Let's take a sum 7.16 bar. What it actually means is that 7.166666 and so on forever. This bar indicates that the 6 goes on repeating for infinite number of times, and that's all the function of the bar. So to further solve it and make it a fraction, what we need to do is shift this decimal point over here once to the place just before the recurring term and once right after it. So the way to do it is multiplying the number by 10 bases. So we can multiply it by 10 once to shift the decimal a point to the right, and then by 100 to shift the decimal 2 points to the right. So let's just do it. We have 10x that is equal to 71.6 bar, which means that it's 71.6666 and so on forever. Now we'll multiply it by 100. So 100x is equal to 716.6 bar, which is 716.6666 on and on forever. Now you see these 6's are aligned, so if we subtract these terms, what we will get will be eliminated, and these terms right here will get rid of them. And my negative sign is not visible here. Okay, there it is. Consider it. So now we'll just subtract it, and what we are left with is minus 90x, which is equal to minus 645. So x is equal to 645 over 90, which we can cancel by 43 over 6. That's the times table of 15. Now we'll just move on to some more real estate which I have stored downwards, and there we have another sum. So now we'll do it by another method, but before we do it, we'll do some easier sums so that you get a hang on what we're doing. So here's a sum 2.83 bar. Okay, well, let me do it in different colors first. So let the 2.8 be in that, and I'll just change the color of the 83. Now our 83 will be in a different color. So here we have 83 bar, and all that means is that what? Okay, all that means is that we have 2.838383 repeating on forever. I just hope you get the color change there. And now we will have two terms in this sum, that is, one will be our x term and the other will be our sum term. So in the x part, all we're gonna do is take these numbers and then take this term before the decimal as a 1, all of this. No matter here you have a million or a trillion or a billion or whatever, it will always be 1, so we'll take a 1 for that. And then the number of zeros, as many digits are there after the decimal. So we have 2 digits here after the decimal, we'll put 2 zeros. And then we'll put a minus sign, and then we'll subtract the number of digits which are not reoccurring. So here our 2 is not reoccurring, the other numbers are, so we'll just subtract the 1 because all the numbers before the decimal are 1. So what's left here is a 99, and just put an X here without asking me where it came from because I have no idea. So here we have our sum part in which we'll write the whole digit without the decimals, that is 283, and then we'll subtract the digits which are not reoccurring. So the 83 is going on repeating, but the 2 is not, so we'll subtract 2 from it, and what we're left with is 281. So you have it. 99x is equal to 281. So we can just divide it maybe, and no, actually not. It's not divisible, and I'll just give you a more easier way to do these types of sum. When you don't have any non-recurring digit after the decimal, what you can do is just take the digits without the decimal and subtract the digits which are not reoccurring. So what you're left with is a 281 here, and all you got to do next is write that term which you got and divide it by as many nines, as many recurring digits you have. You have 2 recurring digits here, so put 2 nines under it. Where am I? Okay, so put 2 nines under it, and there you have the answer. Now we'll move on to one more sum in which we have a non-recurring digit after the decimal. So let's try one of those kinds so you get a hang on what we're doing. Now I'll be using 3 colors in this one. 2.6 and then something funky, blue, 1 bar. So what it actually means is that you have a 2.6 and then an infinite number of ones. 1, 1, 1, 1, and as many ones as you can put along. I don't have enough. So what we're going to do is again solve it with our method. That is, we'll take a x part, and in that we'll write this number as a 1 and these two as 2 zeros, so that's 100. And then we'll subtract this one and this zero, because it's non-recurring even though it's after decimal, so it will be our 0, and what we get to subtract is a 10, and what we're left with is a 90, which we will tag along with an x. And then we'll go to the sum part by something bright like red. So in sum part we have 261. So there we go, 261, and from that we will subtract 26 because 6 is here which is not repeating. We'll subtract 26 from it, and what we're left with is a 235. Now what you got to do next is write 90x equal to 235, and that shall give you x equal to 235 by 990. I hope my 9 is looking cool. Well, yes it is. By 90. Consider it. Now there's one more method you can do it with, and that's just similar to the previous one. What you got to do is that we consider this whole number as an x. So to do it by the previous method, all you can do is consider it 10x, because if you multiply it by 10, what you get is 26.1 bar, and that's the similar term as the previous one. Here you again have the recurring term right after this point. Now we'll move further to some more creative space. Oh, the sheet is really small. Okay, so here we are, and what we're gonna do next is I'm gonna show you the special case sum. And this is our special case, not because it has a different method, but because it doesn't have a method at all. You have 0 point anything reoccurring, and what you can do with this is you can just write the term as it is and put it over as many 9s, as many digits are there. Here we have 2 digits, we'll put 2 9s. And then, so that my mom doesn't get angry on me, I'll cancel them by a 3. So what we have here is 33 over 30. No, sorry, I pronounced it wrong. It's 13 over 33. That was the denominator, and we're done.